Welcome back. In this video, again, I discussed this worksheet entitled Prefixes and Scientific Notation. So if you've been following this playlist, we've discussed already SI prefixes in the previous videos, and we also have started discussing scientific notation. And what if now we'll have this too? Can we convert from one form to another? Okay, so just to recall, SI prefixes are this. So in this table, kilo means 10 to the 3 or simply 1000, and its equivalent, somehow on the other end, is milli. Milli is 1 over 10 to the 3, or basically it means 10 to the negative 3. So if kilo is 1000 times, milli is 1 over 1000 times, or simply 1000 times smaller. So if kilo is bigger than the unit 1000 times, milli is smaller than the unit by 1 over 1000, or smaller by 1000 times. Okay, so when we have this, we can rewrite this actually like this. Decis, instead of 1 over 10 or 0.1, we can write this as 10 to the negative 1. So when the exponent is negative, I think it's obvious now that we can tell that these numbers are small. Okay, this will be 10 to the negative 6, while the other end, there are big numbers. Now let us try to have an example. Like, what if we want to convert 36 kilometers, okay? Convert that into standard scientific notation. Well, without the prefix. So how do we do this? We are asked to convert this into standard scientific notation without the prefix. Well, you could think it this way. 36 kilometers, if you convert that into meters first without the prefix, okay, without the prefix, it will mean what? 1 kilometer, so that's simply 1000, or I normally prefer to write it like 1 times kilo means, okay, if we can recall our approach, kilo means 1000 or 10 to the 3. Okay, in this case 1000 is just 10 to the 3 meters, and here it simply means that what? We multiply 36 by this 36,000, it becomes 36,000 meters. And if we convert this to scientific notation, the standard one, we just move the decimal place. The decimal is supposed to be here. If we don't see any, it is at the end of the whole number, and we just move it until we get only one digit to the left, non-zero digit to the left of the decimal. So 1, 2, 3. We don't end here, but we move one more step so that we only have 1 here, 3.6. 3.6 times 10 to the what? 3.6 times 10 to the, in this case, how many steps did we move the decimal? 1, 2, 3, 4 times 10 to the 4 meters. Okay? So in summary, 36 kilometer can just be written as 3.6 times 10 to the 4 meter. Or if you want a shorter way of doing this, you will just have like this. 36 kilo means times 10 to the negative 3, 10 to the negative 3 meter. And if you convert that into standard scientific notation, since the decimal is here, we move it to the left. So it means now not times 10 to the negative 3 here, positive 4. Positive 3. Made a mistake. So it will be now 3.6 times 10 to the 4, because we add 1 to the decimal, to the exponent, because we move decimal one step to the left. But of course, if you get confused by this, you can just do multi-step like this one. Even though this is a bit longer, this approach is a bit longer, but as long as you get it, it's better than being confused. Okay, as long as you know what to do, even if it takes a little bit more time, that's better than doing it the shorter way, but you are not sure, you're not confident of what you're doing. Now let's take another example. Okay, here. So what if we have 0.05 megawatt? Okay, we are asked to convert this into standard scientific notation without the prefix. So how do we do this? Well, the mega is 10 to the 6. It's a million. So 0.05 times 10 to the 6 watts. So now we get rid of the prefix. Okay? So it's 0.05 times 10 to the 6 watts. And if you want to convert this to standard scientific notation, we can just move the decimal now one step. I mean, if we move there, we're not supposed, it's a common mistake here. So some will just do one step. They move the decimal one step and say, okay, I now got now a number 0.5. But no, we are looking for a number, one digit number to the left of the decimal. In this case, all the digits are still zeros. So we need to do two steps. 1, 2. Until now we got a 5 before the decimal, at the left of the decimal. So it will now be 5 times 10. Now since we move two steps to the right, it means we subtract the exponent by 2. So 6 minus 2 is now 4. Okay? Now you can also do multiple steps like this. 0.05 megawatts. 0.05 times 1 million is just what? 50,000. And from the 50,000, you can then go back and express this into scientific notation. So starting here, decimal is here. 1, 2, 3, 4. Until you reach a one-digit number to the left of the decimal. So it's just the same as 5 times 10 to the 4 watts. Okay? Hope that helps. Okay, let's take this exercises, but again I make some, we'll only do the ones in red, the one that I wrote, because again you are supposed to be the one who do the exercises here on the worksheet. So let me just go directly into this one. 320 microfarad. So it's a very common thing in like electronics engineer, electrical engineers to deal with this, because these are capacitors. Okay, a very important microelectronic device. Now, how do we convert this into standard scientific notation in base units? Meaning you don't want to see micro in your final unit, just farad. Okay? So if you go back to the table, the list of SI prefixes, micro means what? It means micro means 10 to the negative 6. So instead of having micro, we'll just have 320 times 10 to the negative 6 now farad. So as easy as that. Okay, so if we look at the table, we see micro, it's 1 over 1 million, or just 10 to the negative 6. So instead of having 320 microfarad, we now have 320 times 10 to the negative 6 farad. But again, this one is not yet our answer, because this is not in standard scientific notation form. This is scientific notation but not standard, in the sense that we don't have, the number here is not between 1 and 9. So what shall we do? Since the decimal here is assumed to be here, it's a whole number, so the decimal is at the end, we just need to move it until we reach one digit number to the left of the decimal. So how do we do it? Let's do it this way. 1, 2. So we move the decimal place 2 steps towards the left. So it means that we need to add to our exponent. Add 2. Okay? So negative 6 plus 2. So what will that be? It's negative 4. So it will now be 3.20 times 10 to the negative 4 farad. Okay? That's how we do it. Remember that when we move the 320 is a big number, right? It's bigger than 1. So it's best that its exponent must be positive. So plus 2, we add it to the existing exponent, negative 6. It becomes now negative 4. How about this one? 2016 mm. Now, some students will be confused on what does this mean. M, if you look at the SI prefixes, M means milli, right? And milli is 1 over 1000, or 10 to the negative 3. So if we have that, milli, but what is this? Milli? No, it's not milli, because the prefix, there's only one prefix and it's followed by a unit. It's supposed to be millimeter, okay? So in this case, 2016, it means 2016 And milli means times 10 to the negative 3. But there must still be a unit left, in this case meter. Okay, this m here means meter. Okay, now 2016 times 10 to the negative 3, if you want this to be written in standard scientific notation, then you need to move the decimal here, so it's here. How many steps? Until we move it to the left until we reach only one single digit. So 1, 2, 3. So we end there because we get now a 2 on the left of the decimal. So this will just be equivalent to 2.016. How many steps did we take? 1, 2, 3. Oh, 3 steps. So we add to our existing exponent 3 since we're moving towards the left. So 2.016 times 10 to the 3 minus 3. So what will that be? Well, 3 minus 3 is 0. 2.016 times 10 to the 0. And luckily, we're happy because 10 to the 0 is just 1. So it's just 2.016. Okay, times 10 to the 0, or I think it's still best to write this as just 2.016, or let me check the answer key on how do the teacher really want this to be written. Okay, so this one, the final form could be just 2.0. We want in scientific notation really, so it will just be 2.016 times 10 to the 0 meters. Okay, it's equivalent also to this, but we just write it in this form because we want the scientific notation form. Thank you.